As we know, in the world of movies, some things just cannot be physically possible for the sake of audience enjoyment, but the Fast and Furious collection tops the list. Today, we'll be looking at a clip in Furious 7, specifically the one where Dom and his crew parachutes their cars out of a plane in order to ambush an enemy. Anyways, let's see the clip.
Just when you didn't think it could get any better, huh? Oh, shit. Now we're moving. Hey, everybody good? Everybody make it out?
Houston, tell him that this is not for you. This is not your mission.
Hey, Rom? Hey, what's up, man? Talk to me. Come on.
I can't do it.
The hell you can't! Come on, man. You throw that thing in reverse and get your ass out here now.
Look, I can't do it, okay? Listen to what I'm saying.
Now isn't the time.
I'm gonna stay up here with the pilot.
Let's pause here and take a look at Brian's altimeter, which displays 7,626 feet, which is around 2,324 meters. This gives us the second point in its altitude, but we still need the original altitude in order to find the total distance traveled during that time. Luckily, with them digging online, I was able to find the data to be 12,000 feet, also 3,658 meters. From these two numbers, we could find out the altitude decrease was actually 1,234 meters. In order to verify this distance, we first need to find out the point at which terminal velocity is reached by the car. Since the shape of the car is complicated, I'm just assuming in this case that it is falling tail first and the surface is completely flat. The car Brian drives here is a 2012 Subaru Impreza, and we could use that information to find out all the variables and plug it into the terminal velocity equation, which ends up giving me the value of 94.07 meters per second. Now that we have the terminal velocity of the car, we could use one of the big five equations to solve for the time it would take to get to terminal velocity. Since we already have v2 and acceleration, all we have to do is find v1. We saw that the car left on an incline, so we would need to find the y component of its initial speed, which can be found by using the car's 0 to 60 time. It is 5.4 seconds, according to an online website. And then we use the equation delta v over delta t to find acceleration. So 60 over 5.4 is approximately 11.1 miles per hour per second. Then we use that value and multiply it by the time the car spent on the incline to get the speed at the end. So 11.1 multiplied by 1.2 seconds, which is the amount of time the car spent on the ramp, we get a value of 13.3 miles per hour. When we convert that to meters per second, we get a value of 6. Now, we need to find out the y component of 6 based off the triangle the door and the ground makes. From the blueprints online, I was able to find out the height to be 1.04 meters. We can also find out the length of the hypotenuse because we know the acceleration and time. So we could use 1 half a delta t squared. Once we plug in all the variables, we end up with a length of 7.1 meters. Now, we have both length, we could use a formula cosine equals adjacent divided by hypotenuse to find out the cosine of the angle. And we use the inverse function to find out the angle is around 82 degrees. Now, I apply the same equation, but I manipulate the equation so that it gives me the opposite, which is also the y component. So cosine of 82 multiplied by 6 is around 0.88 meters per second, and that is my y component. Now, I just plug this variable into my initial equation, which gives me time. I subtract 0.88 and then divide it by 9.8 to get 9.5 seconds, which is the time needed to reach terminal velocity. Then, I use the time to find out the distance traveled between the initial jump and the point at which terminal velocity is reached. Using delta d equals v1 delta t plus 1 half a delta t squared, I can plug everything in and I end up with 479 meters of travel. Then, I subtract the time it took for him to reach terminal velocity to get the time he spent during terminal velocity. I get a value of 42.5 seconds. Now, I use v multiplied by delta t to find the displacement, which is 3,998 meters. Now I add 479 meters to 3,998 to find a total distance traveled, and it does not equal 1,334 meters. Even though there were some assumptions made, there's no way it could account for the large difference between the calculations and the actual event in the movie, so we can confidently conclude that this scene is physically impossible.